Welcome back to Techness Arena, your ultimate destination for all things tech. In today's video, we have an exciting topic that's essential for anyone looking to dive into the world of programming. We'll be discussing Python mastery, from absolute beginner to pro level. Whether you are just starting out or are looking to enhance your skills, this video is for you. So let's go. Python is a versatile and powerful programming language known for its simplicity and readability. From its humble beginning to becoming one of the most popular languages, Python has gained immense popularity due to its ease of use, extensive libraries, and wide-ranging applications. This video can be somewhat long as I'm covering a wide range of topics. Also at the end, I'll be explaining about what the career opportunities are there after becoming proficient in Python. Many things to explore it. So have patience, pay attention, and finish it. Let's jump into it right away. The first one is Python basics, as always, obviously. Python basics refers to the fundamental concepts and syntax of the Python programming language. It includes topics such as variables, data types, operators, control flow, that is if statements, loops, etc., functions, modules, input-output, file handling, and exception handling. Understanding these basics is essential for writing and understanding Python code effectively. So, let's go in some more depth. In Python, variables are used to store data values and they can hold different data types such as numbers, strings, and booleans. Operators are used to perform operations on variables and data such as arithmetic, comparison, logical, and more. Control flow in Python allows you to make decisions and repeat actions based on certain conditions. If statements are used to execute different blocks of code based on whether a condition is true or false. Loops like the for and while loops allow you to repeat a block of code multiple times. Functions are reusable blocks of code that perform specific tasks. They help organize code and make it more modular. Modules are files that contain Python code, including functions and variables, which can be imported and used in other programs. Python provides built-in functions to handle input and output operations. These functions allow you to take user input, display output, and work with files. File handling involves opening, reading, writing, and closing files using file objects and specific methods. Exception handling is a way to handle errors or exceptional conditions that may occur during program execution. By using try-except blocks, you can catch and handle specific exceptions, allowing your program to gracefully handle errors and prevent crashes. Then, second is data structures. Data structures are containers or formats used to organize and store data efficiently. They provide different ways to store, manipulate, and access data elements. Here are the explanations for the specific data structures. Lists are ordered collections of items, allowing duplicate and mutable operations. Tuples are similar to lists but immutable. Dictionaries are key value pairs, providing fast lookup based on unique keys. Sets are unordered collections of unique elements, useful for performing mathematical operations like union, intersection, and difference. Frozen sets are immutable sets. NumPy is a library in Python that introduces arrays, which are similar to lists but optimized for mathematical operations and handling large data sets efficiently. Arrays provide fast element-wise operations and allow vectorized computations. Pandas is a powerful library for data manipulation and analysis. Series are one-dimensional labeled arrays, while data frames are two-dimensional labeled data structure similar to tables. They offer convenient methods for data cleaning, filtering, and aggregation, making data analysis tasks easier. Then next is file handling. File handling is the way we interact with files in a computer program. It allows us to read information from files, write data to files, and manipulate files in various formats. In Python, we can open a file using the open function and then read its contents using methods like read or readlines. To write to a file, we open it in a write mode and use methods like write or writelines to add data to the file. CSV and JSON are commonly used file formats for storing structured data. CSV is comma separated values and JSON is JavaScript object notation. CSV files store data in a table-like format with values separated by commas. JSON files store data in a human-readable format using key-value pairs. Python provides convenient libraries such as CSV and JSON to read and write data in these formats, simplifying the handling of CSV and JSON files in Python programs. Then next is string manipulation. String manipulation involves modifying, extracting, and manipulating text in a computer program. It allows you to perform operations on strings, such as combining them together, splitting them into smaller parts, finding and replacing specific words or characters, and changing their case. String operations in Python provide a wide range of functionalities for working with strings, including concatenation, splitting, searching, replacing, and changing case. These operations give you the flexibility to manipulate strings according to your needs. Then, next is object-oriented programming. Object-oriented programming is a programming paradigm that organizes code into objects, which are instances of classes. It focuses on modeling real-world entities as objects that have attributes, that is data, and behaviors, that is methods. In OOPS, a class is a blueprint or template that defines the structure and behavior of objects. It encapsulates data and methods. An object, in a different way, is an instance of a class. It represents a specific entity with its own unique state and behavior. Inheritance allows a class to inherit properties and methods from another class, known as the superclass or base class. Promotes code reusability and enables the creation of specialized classes called subclasses or derived classes. Polymorphism refers to the ability of objects of different classes to be treated as objects of a common superclass. It allows methods to be overridden in subclasses, providing different implementations while maintaining a consistent interface. Advanced OOP concepts include abstraction, encapsulation, and interfaces. Abstraction focuses on hiding unnecessary details and exposing only essential information. Encapsulation involves bundling data and related methods into a single unit, preventing direct access to the internal state of an object. Interfaces define a contract that classes must adhere to, specifying the method they should implement, promoting loose coupling and modularity in code design. Next is modules and packages. Modules and packages are essential components of modular programming in many programming languages, including Python. They provide a way to organize and reuse code by dividing it into separate files and directories. In Python, a module is a file containing Python definitions, functions, and statements. You can create your own modules by writing code in a separate .py file. To use a module in another Python script, you import it using the import statement, which allow you to access its functions, variables, and classes. A package is a way to organize related modules into directories. It helps manage large projects by grouping related functionality together. A package is simply a directory containing a special file called init.py. To use a module from a package, you specify the package name followed by the module name using dot notation in the import statement. Overall, modules and packages provide a way to organize code, improve code reusability, and make the development process more efficient and manageable. Next is error handling and exceptions. Error handling and exceptions are mechanisms in programming that allow for the detection and management of errors or unexpected events that may occur during the execution of a program. Error handling involves anticipating potential errors and implementing strategies to handle them gracefully, preventing program crashes or undesired behavior. It includes techniques like try except blocks, where specific code segments are wrapped in a try block and potential errors are caught and handled in except blocks. Try except blocks are used to catch and handle exceptions. The code within the try block is executed, and if an exception occurs, it is caught by an except block that matches the specific exception type. This allows for controlled error handling, such as displaying an error message, logging the exception, or taking alternative actions to recover from the error and keep the program running smoothly. Next one is functional programming. Functional programming is a programming paradigm that emphasizes the use of pure functions, where the output is solely determined by the input and has no side effects. It focuses on treating computations as the evaluation of mathematical functions and promotes immutability in higher order functions. Lambda functions, also known as anonymous functions, are functions without a name. They are defined in line and typically used when a function is required for a short and simple operation. Lambda functions are concise and can be passed as arguments to other functions. Map, filter, and reduce are higher order functions commonly used in functional programming. The map function applies a given function to each element of an iterable and returns a new iterable with the transformed values. The filter function selects elements from an iterable based on a given condition. The reduce function applies a binary function to the elements of an iterable, reducing them to a single value by iterably combining the elements. These functions facilitate a functional programming style by allowing operations to be expressed concisely and elegantly, promoting code readability and maintainability. Next is iterators and generators. Iterators and generators are features in Python that enable efficient and controlled iteration over a sequence of elements. Iteration protocols define the set of methods that an object needs to implement in order to be considered an iterator. The two essential methods are iter, which returns the iterator object itself, and next, which retrieves the next element in the sequence. By following these protocols, objects can be iterated using a for loop or by explicitly calling the next function. Generators are a type of iterator that can be created using a special syntax with the yield keyword. They allow you to define a function that behaves like an iterator, generating values on the fly without storing them all in memory. Generators are useful when dealing with large or infinite sequences. Next is decorators. Decorators in Python are a way to modify or enhance the behavior of functions or classes without directly modifying their source code. Function decorators are functions that take another function as input and returns a modified version of it. They provide a convenient way to add additional functionality to functions, such as logging, timing, or input validation, by wrapping the original function with the additional code. Class decorators work similarly to function decorators but operate on classes instead of functions. They can be used to modify the behavior or attributes of a class. Class decorators are applied using the @decorator syntax above the class definition. Next one is working with dates and times. Working with dates and times involves manipulating and managing date and time values in programming. In Python, the datetime module provides classes and methods to handle dates, times, and durations. The datetime module provides classes such as datetime, date, time, and time delta to work with dates, times, and durations. These classes offer methods to perform various operations like creating date or time objects, extracting specific components like year, month, day, hour, etc., performing arithmetic operations, and formatting dates and times. Next one is Python Standard Library. The Python Standard Library is a collection of modules and packages that come bundled with Python. It provides a wide range of functionality, including file operations, system interactions, mathematical calculations, random number generation, and much more. Next, working with databases. Working with databases involves interacting with structured data storage systems, enabling the storage, retrieval, and manipulation of data. In Python, this is achieved through modules that provide database connectivity and SQL support. Then, regular expressions. Regular expressions, that is regex, are powerful tools for pattern matching and text manipulation. They provide a concise and flexible syntax for searching, extracting, and manipulating text based on specific patterns. In Python, the re module is used to work with regular expressions. The re module in Python allows you to work with regular expressions. It provides functions like match, search, find all, and sub to perform various operations on strings using regex patterns. These functions enable pattern matching, extracting specific text, replacing text, and more. Regular expressions provide a flexible and efficient way to handle complex text processing tasks, allowing you to leverage the power of pattern matching for various purposes like data validation, parsing, and text manipulation. Next one is debugging and testing. Very important. Debugging and testing are crucial aspects of software development that help identify and resolve issues in code and ensure the correctness and reliability of the software. Debugging is the process of finding and fixing errors or bugs in code. Python provides the PDB module, which is a built-in debugger. It allows you to set breakpoints, step through code execution, inspect variables, and analyze program flow to identify and fix issues. Unit testing is a method of testing individual units or components of software to ensure they function correctly. The unit test module in Python provides a framework for writing and executing unit tests. It allows you to define test cases, test functions, and assertions to verify expected outcomes. By using debugging techniques and writing comprehensive unit tests, developers can identify and fix issues during development and ensure the reliability and correctness of their code. Next is performance optimization. Performance optimization refers to the process of improving the efficiency and speed of a program or system. It involves identifying bottlenecks and implementing changes to enhance its performance. The timeweight module in Python is used to measure the execution time for small code snippets. It helps in benchmarking different approaches and comparing their performance. cProfile is a Python module used for profiling code, which means analyzing the execution time of different functions and identifying areas that consume the most resources. It provides detailed information about the time taken by each function, helping developers optimize their code by focusing on the critical sections. Both timeweight and cProfile are valuable tools in performance optimization as they help developers understand where their code is spending and the most time and resources, enabling them to make informed decisions on how to improve its efficiency. Next, virtual environments and package management. Virtual environments and package management are crucial aspects of software development and deployment. Virtual environments provide isolated environments for Python projects, allowing developers to have separate Python installations and packages for different projects. This helps avoid conflicts between dependencies and ensure project-specific requirements are met. Python provides built-in modules like Venv and external tools like Conda for creating and managing virtual environments. These tools allow developers to set up isolated environments with specific Python versions and packages, enabling them to work on different projects without interference. Package management tools like pip are used to install, upgrade, and manage external packages and dependencies within a virtual environment. pip simplifies the process of adding new packages to a project, ensuring the required libraries are readily available for use. By using virtual environments and package management tools, developers can maintain clean and organized project structures, easily manage dependencies, and ensure consistent and reproducible environments for their Python projects. Last but not the least, Python best practices. Python best practices refer to the recommended guidelines and approaches for writing clean, efficient, and maintainable Python code. It covers aspects such as indentation, naming conventions, line length, and code structure. making the code more readable and easier to understand for other developers. Including docstrings in functions, classes, and modules is essential for documenting the purpose, uses, and parameters of the code. Docstrings serve as self-contained documentation and provide valuable information for developers who might need to use or modify the code in the future. Utilizing version control systems like Git and collaboration platforms like GitHub facilitates efficient code management and collaboration among developers. Version control allows tracking changes, branching, and merging, while platforms like GitHub provide a centralized location for hosting code repositories, merging issues, and facilitating collaboration through features like pull requests. By adhering to these Python best practices, developers can enhance code readability, maintainability, and collaboration, leading to more efficient development workflows and improved code quality. After mastering Python, you open the door to a wide range of exciting and rewarding career opportunities. Here are some of the paths you can pursue. First, software developer or engineer. Python is extensively used in software development, making it a valuable skill for becoming a professional software developer or engineer. You can contribute to building robust applications, web development, data analysis, scientific computing, and much more. Second, data scientist. Python's extensive libraries such as NumPy, Pandas, and scikit-learn make it a top choice for data science and analysis. With Python mastery, you can work with large datasets, perform complex data manipulation, develop machine learning models, and gain insights from data to drive business decisions. Third, machine learning engineer. Python is widely used in the field of machine learning and artificial intelligence. TensorFlow and PyTorch enabling you to develop and deploy machine learning models for various applications. Fourth, data engineer. Python's versatility extends to data engineering tasks, including data extraction, transformation, and loading, shortly called as ETL. With Python, you can automate data workflows, build scalable data pipelines, and work with big data technologies like Apache Spark. Fifth, DevOps engineer. Python's simplicity and vast ecosystem make it an excellent choice for automating deployment, configuration management, and infrastructure orchestration. With Python expertise, you can pursue a career in DevOps, ensuring smooth and efficient software delivery and infrastructure management. Sixth, web developer. Python's web frameworks like Django and Flask empower developers to create dynamic, scalable, and secure web applications. Mastery of Python equips you with the skills to develop backend logic, handle databases, and build robust web APIs. 7. Cybersecurity professional. Python is commonly used for various cybersecurity tasks such as penetration testing, vulnerability assessment, and security automation. With Python proficiency, you can contribute to strengthening the security of systems and networks. 8th, freelancer or consultant. Python's popularity and versatility make it an in-demand skill for freelancers and consultants. You can offer your expertise in Python development, data analysis, automation, or specialized domains to clients across industries. Mastering Python opens a vast array of career opportunities across industries like technology, finance, healthcare, e-commerce, and more. The versatility and a wide adoption of Python ensures that your skills remain valuable and in high demand in the ever-evolving world of technology. That concludes our Python mastery video. We've covered everything from the basics to advanced concepts, giving you the necessary foundation to excel in Python programming. Remember, practice is key, so you need to code, implement, explore, and challenge yourself to achieve success in the field. If you enjoyed this video and found it helpful, be sure to hit that like button and subscribe to TechNecessary for more informative tech content. Thanks for watching, and until next time, happy exploring.